Let us see an example. Trace the curve y square equal to x raised to 5 2a minus x. Suppose equation 1. Now first rule to check the symmetry. So for that we need to check the powers of x and y. Now here y has even power, here x has power 5. If you multiply with this x has power 6. So x has two powers, odd and even, but y has only even power. So since even powers of y only exist, therefore we say symmetry about x-axis. Next we first check the point of intersection. So for point of intersection, first we check whether it passes through origin. So for that, put x is equal to 0. So if we substitute x equal to 0, we obtain y square equal to 0, ultimately y equal to 0, and therefore we say curve passes through the origin. Also y square equal to 0, that means we get y is a double point. So y is a double point, therefore now we need to check what is the nature of this double point, whether it is a node or it is a cusp. Now that depends on the tangents. So for the tangent and equating the lowest degree term to 0. So the lowest degree term here in the equation is y square equal to only. So y square equal to 0 gives me the equation y equal to 0. So that is nothing but x-axis. Therefore x-axis is the tangent at origin. So we can obtain only one tangent at origin, that is the x-axis. So there obviously this is a double point, and now this double point will be known as a cusp, as it is a only coincident, it has a coincident tangent passing through this point. So double point is a cusp. Next we need to find few more points of intersection with coordinate axis. So for that, put y is equal to 0. So y equal to 0, that means x raised to 5 into 2a minus x equal to 0. We obtain x equal to 0 and x equal to 2a. So we obtain one more point of intersection with respect to x-axis as 2a comma 0. So 2a comma 0 be the point of intersection at x-axis. Next we check the whether there is any tangent passing through this point to the curve. So for that we find the differential term, that is dy by dx. So differentiating equation 1 and given equation with respect to x-axis, we obtain 2y dy by dx is equal to 10a into x raised to 4 minus x 6 into x raised to 5. Therefore dy by dx is equal to so this term 5a x raised to 4 minus 3x raised to 5 upon y. So at point 2a comma 0, dy by dx is equal to infinity, and that means I can say that exists a tangent parallel to y-axis at this point 2a comma 0. So suppose there exists a tangent, we draw the tangent as here. Suppose this is the tangent. Next we find few more special points, or you can say few more points, so that it will be easier to trace the curve. So now suppose I substitute x is equal to a in the given equation. So in the given equation, if you substitute x equal to a, this becomes a raised to 5 2a minus a, that is a, so a raised to 6, means we obtain y square equal to a raised to 6, that means y is equal to plus or minus a cube. So we obtain two values of y at x equal to a. So at x equal to a, suppose these are the 2 points. So through this curve will pass. We also see now the region of absence of curve. Region of absence of curve means where the curve does not lie. So now suppose I substitute some value which is less than a at x in place of x. Suppose x is minus a. So this will become minus a raised to 5 2a minus a, that is a. Ultimately minus a raised to 5 is minus of a raised to 5, means there will be a negative term here, means y square will become negative, that is imaginary. Now if I substitute some value which is greater than 2a, suppose I substitute x is equal to 3a. So this will become 2a minus 3a. So 2a minus 3a, that will be minus a, means y square will become negative, that means imaginary. So for both x less than 0 and x greater than 2a, y square becomes negative. That means I can say curve does not exist for y less than 0 and y greater than 2a. So obviously the curve will now lie between this origin and point 2a. It will not go beyond this and will beyond or in the negative axis. So now if it is the curve, it will be passing through this point, coming here, a symmetry part will exist. So this is a cusp, double point, that is a cusp. It is symmetrical about x-axis. This x equal to 2a is equal the tangent to the curve.